What's up everybody, and welcome to a new video. And in this video we're going to go over my notes for Boolean values in Python and also over my notes for the none value. So let's start with the Booleans. Namely, there are just two different values and they are true and false. And the main use case of Boolean values is for control flow. And we will talk about control flow in more detail later in the series. So therefore now I just want to quickly show you a short example of how the Boolean values are used in that context. Namely, if I here say, for example, if true, and then here let's simply say print do something. So then if I run this, then you can see that this print statement here is executed. However, if I say here if false, then the print statement is not executed. And those are already my main notes for Boolean values. So now let's go over the side notes here. And the first one states that by convention, the comparison operator with the two equal signs is not used when checking if a variable is true or false. So for example, if I create here a variable called some condition, and if I set that to true, then what you not do by convention is to say if some condition is equal to true. And then here let's simply say print do something. So by convention, this is not what you're doing, even though this is working. However, instead, what you do is to simply say if some condition. And then you can see that this print statement here is again executed. So that's the first side note. The second one states then that true is interpreted as a 1 and false is interpreted as a 0. So for example, if I say here true plus 5, then we get here a 6. And if I say true times 2, then we get here a 2. However, if I say false plus 5, then we get a 5. And if I say false times 2, then we get here a 0. So as you can see, true is interpreted as a 1 and false is interpreted as a 0. Then the next side note simply says see also Boolean operators, and I included that here because I think when talking about Boolean values, it's also important to know about Boolean operators. And we have already talked about Boolean operators when we talked about here in the context of coding basics about expressions, and then here different types of operators. And here we have logical or Boolean operators. So if you don't know about them, then I will put the link to that video here into the video description. Okay, so then the last side note here states that NumPy or pandas, which are third-party packages, they enable something called Boolean indexing. And to show that, I have prepared here some example code. So let me copy and paste that. So here, what I'm doing, I'm simply importing NumPy, and then I create this NumPy array containing the numbers -2, -1, 0, 1, and 2. And now what you can do with this array is, for example, to check which of these values here is bigger or equal to 0. So therefore, then you would simply say numbers and then bigger or equal to 0. And then we get here this Boolean array, which contains these values here, where the first two values are false and the last three values here are true. And that's because the last three values here in this array are bigger or equal to 0. And now what you can do with this Boolean array is to use Boolean indexing to index this numbers array here, to only then get the values that are bigger or equal to 0. And the way that you would do that is by saying numbers and then brackets. And then here you can then say you want to only have the numbers bigger or equal to 0. So now if I run this, then we only have this array containing 0, 1, and 2. And this is not possible if we just use simple Python lists. So for example, if I copy this list here, and then here say numbers is equal to that list. And now if I try to say numbers is bigger or equal to 0, then we get here this error because this comparison operator is not supported for lists and integers. Okay, so that's here now the last side note. And with that, now we've covered all the side notes. And with that, then we've covered all the notes I wanted to cover with respect to Boolean values. So now let's go over my notes for the none value. The first one states that the none value represents a null value, i.e. the absence of an actual value. Then The second note here states that the convention when checking if a variable is equal to none is to use the identity operator and not the comparison operator. So for example, if I create here a variable x and set that equal to none, then what you're not supposed to do is to say x is equal to none, even though that's then true here. Instead, what you should do is to say x is none. And then here we also get a true. So that's the second note. And then the third note is then about some typical use cases of the none value. And here our first use case is as a return value in a function. So to show that, I've prepared here this example function. So here this function simply takes in a number. And if the number is bigger than 0, then it returns the number. Otherwise, it returns none. So that is the first use case. The second one is then as a placeholder value for a variable that will be assigned at a later point. And to demonstrate that, I've prepared here the following example. So here we are creating two variables, numbers and highest. Numbers is simply a list of numbers and highest is then here set to none. So this is our placeholder value for this variable. And then here we simply loop over those numbers here over the list. And then we check if highest is none or if n is bigger than highest. And if that's the case, then we set highest equal to n. So then here, if I print out the highest, then we get here a 3, and because this 3 here is the highest number in this list. So that's the second use case. And then here the last one is as a default value for a parameter to avoid a potential problem with mutability. And we talk about mutability when we talk about here data structures, and then the miscellaneous topics, then here we have mutability. Namely, there are some situations where mutability might cause a problem. And one of those situations is the default values in function definitions. So if you want to know more about that, then I will put the link to that video into the video description. But for now, I just want to quickly show you what I mean by that. Namely, here I have prepared this function. So here, this parameter is set to the default value of this empty list, and a list is a mutable object. So this is something that you're not supposed to do. Instead, what you should do is the following. So here, if I copy this, paste this function, instead what you should do is set this parameter equal to the default value of none. And then within the function, if that parameter is none, then you create here this mutable object. Okay, so those are the three use cases or typical use cases of none. And with that, now we've covered all the notes that I want to cover with respect to the none value. So with that, now we've reached the end of this video. And then in the next video, we're going to start to go over my notes for data structures in Python. So thanks for watching, and hopefully I will see you in the next video.